All right, in this video, we're going to work on proving square root of 2 is irrational. And the technique we're going to use is something called proof by contradiction. So what that means is if we have two events in life and one is the opposite of the other, we'll call them A and B. If B happens, then there's no way A could be true. If A happens, there's no way B could be true. So in this case, we're going to assume the square root of 2 is rational, which is the opposite of irrational. If a number is rational, it cannot be irrational. If it's irrational, it cannot be irrational. Well, if we're going to assume that to start, the definition of a rational number is a number, P over Q, such that Q cannot be 0, and P and Q are simplified. You can't simplify them anymore. So these are the two parts of this definition. So if square root of 2 is rational, we know that P over Q equals square root of 2. Let's get rid of the radical by squaring both sides. So we've got P squared over Q squared equals, the radical goes away, we've got 2. Next step, we cross multiply. We've got P squared equals 2Q squared. Now here's a good stopping point for you. If P squared equals 2Q squared, then that tells you that P squared is even, because we've got the 2. P squared is even. But we can take this a step further. If you multiply an odd number by an odd number, you always get an odd number, which means P must be even as well. Because P times P has to be even, which means P is even. So this is the first part of this proof that I want you to stop and think about. So if P is even, then we know that P equals 2K for some integer K. Because even numbers 2 times a random integer K. Well, what that means then is P squared equals 2, we got P squared equals 2K squared, right? If P is 2K, P squared is 2K squared. P squared equals 4K squared. But we know that P squared equals 2Q squared. So we've got 2Q squared equals 4K squared. We can simplify. If we divide each side by 2, this goes away, and we get Q squared equals 2K squared. Well, guess what? Just like over here, we now know that Q must be even, or I'm sorry, Q squared is even, because we're multiplying by 2. And because of what I told you before, an odd times odd is always an odd, this means that Q must be even. Here are the two key points to solve our proof. If P is even and Q is even, and we assume that radical 2 is rational, so P is even and Q is even, and the definition of a rational number is P over Q, but they're simplified all the way down. If P and Q are both even, they're not broken all the way down. So pretend we have P is 8, Q is 2. It's not simplified because you can have 4 over 1. So if you plug in any even number for P and Q, you can always simplify it. Because they're not simplified, we've just violated this of the rational numbers, which means this cannot be true. And if this cannot be true, we've just proven that radical 2 is irrational. Proof by contradiction. Thank you for watching.